Hey guys, in this video we are talking about what effect there is on momentum when two objects collide with each other. So there's three situations. The first one is when the objects hit each other, but they don't stick together. They bounce off each other and keep going the opposite direction of their initial. So what I would do first is draw a picture. So in our before picture, we've got one mass going to the right and another mass going to the left. And I've said that the right direction is what I'm going to call the positive direction. After the collision, after they hit, M1 is going the opposite way that it was before, and M2 is going the opposite way it was before. And I'm still referring to the positive direction as the one to the right. So what I've written down here, I have M1I, that means M1 initial, V1I, V1 initial, M2I, M2 initial, V2I, V2 initial, and over here I've got my finals, the initial, the final mass, the final velocity, the final mass, and the final velocity. So let's say that M1 is equal to 0.3 kilograms. So its weight doesn't change, so M1 is going to be the same before and after the collision. Originally, it had a velocity of 5, and after the collision, it has a velocity of negative 2.2. The second mass originally was 0.4. The mass is going to stay the same. It originally was traveling negative 4.5 meters per second, and after the collision, its velocity is what we're trying to find. That's our unknown. So what you always want to do first is say momentum before equals momentum after. Momentum is described as mass times velocity. So this mass has momentum and this mass has momentum. So the momentum before is the mass times the velocity of the first one plus the mass times the velocity of the second one. And that's going to equal the mass times velocity of the first one after. I'm going to say M1 final, V1 final, plus M2 final, V2 final. Nope, that says V. Should say M. And I'm just going to add my initials over here. So M2 initial, V2 initial. You can use any sort of symbols that you want. Anything that works for you is fine. So the first mass was 0.3 times its velocity was 5. So that ball had a momentum of 0.3 times 5, plus the other ball had a momentum of its mass, 0.4, times its velocity, negative 4.5. And that equals 0.3 times negative 2.2 plus the mass of the second one, which was 0.4 times V2 final. Hopefully you can see that over there. And then all you need to do is multiply the stuff in brackets and then add them together. 0.3 times 5 is 1.5, plus 0.4 times negative 4.5 is negative 1.8, and that equals 0.3 times negative 2.2 is negative 0.66, plus 0.4 V2 final. 1.5 minus 1.8 is negative 0.3, and that equals negative 0.66 plus 0.4 V2 final. I'm going to add 0.66 to both sides so that that will go away. Negative 0.3 plus 0.66 is going to be positive 0.36, and that equals 0.4 V2 final. To get V2 final by itself, I'll just divide my 0.4 on both sides so that they'll go away, and I'll get V2 final equals 0.36 divided by 0.4, I get that is 0.9. Remember your units, meters per second, and remember the direction. This is a positive number, and because I let my momentum up here for traveling this way be negative, and my momentum for traveling this way be positive, I don't really need to think too much about the direction. So plus 0.9 meters per second means 0.9 meters per second in that direction. And if you look at our original picture, it makes sense that the momentum will be in that direction. So you can put in 0.9 right up here.